Lesson 25 is about solutions of equations, and it's an application or a combination of Lesson 23 and 24. Before we get started, let's just review the rules that we learned in Lesson 23 and 24. In Lesson 23, we learned that the same quantity can be added to both sides of an equation, and it does not change the solution to the equation. And then in Lesson 24, we learned that both sides of an equation can be multiplied or divided by the same non-zero quantity. I didn't really mention that in Lesson 24, but it does have to be a non-zero quantity. And we don't change the solution to the equation, we just change the way it looks. So in the problems in this lesson, what you'll be doing is using both of those rules that you learned in Lesson 23 and 24 in the same equation. For example, look at practice problem A. 3x plus 7 equals 1. Now if you want to figure out what x is, you'll have to do the addition rule first, then the multiplication division rule. And almost always the way you want to do these problems is to do the addition rule first, then you do the multiplication and division rule. The addition rule, like if we did that first on this practice problem A, we would want to get rid of that positive 7 because that's added on the left side. So to get rid of it, we would have to do an addition type of operation. So let's add a negative 7 to both sides, and then that will cancel the 7's on the left, and we'll have 3x is equal to negative 6. Now we could use the division rule to get rid of that 3. 3 and 3, divide both sides by 3. We have to divide both sides. And then we end up with x is equal to negative 2. And so that would be our solution to that equation, x equals negative 2. On a more complicated equation like this, sometimes it's a good idea to check your work, and you can do that just by substituting your solution back into the expression on the left. And so we would have 3 times negative 2 plus 7. And so that's equal to negative 6 plus 7, which equals a positive 1. That's the number on the right side of the equal sign, and so we have the right solution there. Let's do another one. 1/4 x plus 2/5 equals 1/2. So let's just look at that. First, what we want to do, and this is usually almost always the steps that you do, is do the addition rule first and then do the multiplication or division rule to get rid of your coefficient of x. So step 1 here, to solve for x, let's go ahead and add a negative 2/5 to both sides. And on the right side, I'm just going to add it horizontally because I know that I'm going to have to work with those two fractions, and that just helps me think about the numerators and denominators together a little bit better if they're horizontal to each other. Now on the right side, I'm going to want to add those two fractions together, and I need a common denominator, so 1/2 I would have to multiply by 5 over 5, and then 2/5 would need to be multiplied by 2 over 2. And as you can see, a lot of things in algebra that we do, we don't change the expression, we just change the way it looks. Like multiplying by 5 over 5 is the same thing as multiplying by 1. So we end up with 5/10, but that's the same thing as 1/2. So now let's take 1/4 x on the left, and that's going to be equal to 5/10 plus a negative 4/10, so that would just be 1/10. Now we've got 1/4 to get rid of, and so in order to do that, let's just multiply by its reciprocal, 4 over 1. And so on the left side, the 4 over 1 times 1/4, that's equal to 1, so all that cancels. On the right side, we could reduce first. We can factor a 2 out of both of those, and then we end up with x is equal to 2/5. So in order to solve these more complicated equations where there's addition and multiplication in there, you do the addition rule first. The same quantity can be added to both sides. It doesn't change the solution. And then you do the multiplicative rule, or multiply, divide both sides by the same non-zero quantity. You do that second. You can always tell if you're going to have to use both rules if there's a plus or a minus sign by the x on the side that the x is on, and then also if x has a coefficient other than 1. Look at practice problem C. Let's solve that for x. And so what we want to do is isolate the x. We see that we have addition there on the left side, and we have a coefficient for x. So we'll have to use our addition rule first, then our multiplication division rule. Let's go ahead and subtract 5/6 from both sides. And over here on the right, I'll just put it up there next to the fraction. So this cancels on the left. On the right side, I need to get common denominators there. And so I'll need to multiply negative 5/6 by 2 over 2. And so then I'll end up with 3 1/4 x, or I know I'm going to have to make that an improper fraction, so I'll just go ahead and do that now. 13/4 x is equal to 7/12 minus 10/12, or negative 3 over 12. Now, next step is the multiplication rule. We can take the reciprocal of that fraction and multiply both sides by the reciprocal, which is 4 over 13. So everything cancels on the left side there. On the right side, let's try to reduce that first. 4 over 12 would reduce to 1 over 3. And then we have 3 over 3, which would reduce to 1 over 1. And so x ends up equaling negative 1 over 13. Negative 1/13. Look at practice problem D. This one has decimals in it. And it's a little bit different because the variable is on the right side. But don't get confused by a problem like this. Just go ahead and do it the way you've been doing these. You do your addition rule first, and then do your multiplication and division rule. And your goal is still the same. You're trying to get x by itself. So you wouldn't subtract 1.5 from both sides. You'd end up with 0 on the left side. You want to get rid of that 1.3, and that gets you one step closer to getting x by itself. It's just that x is on the right now. So subtract 1.3 from both sides. And so that cancels to 0 on the right side, and then on the left we have 1.5 minus 1.3 is 1.2. So we'll have 1.2 is equal to 2x. Now we just use our division rule. We can divide both sides by 2. And you probably caught this already. That's 0.2 on the left side, not 1.2. So we divide both sides by 2. And the 2's cancel on the right side there. And so we end up with, on the left, 0.2 divided by 2, which is just 0.1. And so x is equal to 0.1. So that problem was a little bit different in that the variable was on the right side. We still use the same steps. Addition rule first, then multiplication division rule. Let's do one more. 1.5 plus 1.2x equals 7.5. Again, we'll be working with decimals. Let's just follow our rules. Let's do the addition rule first on the left. We recognize that we need to do that because we have a plus sign there on the left side in front of the x variable. And so we'll subtract or add a negative 1.5, however you want to think about it. Add a negative 1.5 to both sides. That cancels on the left. And we have 1.2x is equal to 6.0. Now we need to divide both sides by 1.2. So go ahead and do that. So that 1.2 cancels on the left side, and we have x is equal to 5.0. So that's our answer, 5.0. Okay, so this is a real important concept in algebra, the solution of equations, where you use those two steps, the addition rule and the multiplication division rule. If you're not thinking of being an engineer or something like that, this just develops good problem-solving skills, and so just work hard, have a good attitude about it. If you are thinking of engineering, you're going to use this in all of your engineering when you get to college. So things like this, you need to know them and know them well. Okay, well that's all for lesson 25.